What's up, bros? All right, today we are going to jump in, Precalcsters, into 4.2, and you kind of probably already have some of these notes yesterday, but if you didn't understand them, we're going to review some geometry to really preface today. So in 4.2, our focus is the unit circle. Now, as we go through these things, first thing that I'm not going to write it down, but I do want to make sure that we're all always thinking this. If I say something is a unit whatever, a unit square, a unit pentagon, doesn't matter. Unit indicates we're talking about a length of 1. That's it. So if it's a unit circle, the radius is 1. If it's a unit square, the side length is 1, and so forth and so on. So the unit circle has a radius of 1, and we're going to use that in just a moment. Now, in geometry, in Algebra 2, whenever you've done a little bit of trig, even the other day we were looking at it, there are some special angles that show up all over the place. And specifically with triangles, like I don't think a 49-degree angle is a nice angle to have in a triangle. It's not terrible, but are there any nice angles that stand out? Like just from memory. So 90 is a nice one, right? Now, it turns out that 90-degree angles will be present in every triangle that we do with the unit circle. So I know that we're talking about a circle, but you're going to hear me referencing triangles over and over and over. Those of you that had me in geometry, do you remember me ever talking about bow ties and butterflies? Okay, if you don't, I'll remind you of what that is, but they're all triangles, bow ties and butterflies. We will use that idea. Give me any sort of triangle that you can think of with degrees where 90 degrees is one of them. Like it's probably not 46, 44, 90. That's a weird one. A 45, 45, 90 is a nice one. There's one more super nice one. 30, 60, 90. So we're going to just start today with just a couple ideas. So our first little one is special triangles. Now, these will show up on the unit circle, and I'll show you exactly where they show up on the unit circle as well. But there's two really special triangles. And really, there's a third one. The 60, 60, 60 is also special, but we don't have to use that one. But we might right now. We'll see how much we remember. Let's deal with the 45, 45, 90 first. So we'll just say here's our first little piece, a 45, 45, 90. Okay, an isosceles right triangle is the other way that you might word this. Okay, if I wanted to sketch a 45, 45, 90, the first thing I'm going to do is I'm going to sketch it nicely. I'm going to sketch it here and here. And I'm going to have it as if it's starting at the origin and shooting into quadrant 1. And we'll see where these things come up. Now, if this is a 45, 45, 90, I don't know if I need to necessarily draw the numbers, but these are my 45s, right? Okay. What sort of triangle did I say it was? It's a blank right triangle? Isosceles. What does it mean for a triangle to be isosceles? Two sides are the same. Now, in this case, it'd be the sides opposite from those angles. So hypothetically, that's x, and that's x. If we wanted to find the third side of this thing, and I'll mark it as a right triangle to make sure that we have it. I mean, I know I said it, but we'll mark it here. How can I find the length of the third side? One more time. So Addison's saying Pythagorean theorem, a squared plus b squared equals c squared, but I don't have a and b here. What is it going to be on this one? Like, I'm okay with calling this, I'm going to call it r rather than c, because we'll see why here in a second. Help me Pythagorean this triangle. X squared plus x squared equals r squared. Do we all agree with that? Okay, now, if we are dealing with this, let's just keep going. I want to find r. Let's solve this for r. And there's a reason we're doing it. We're going to see something awesome happens. But we'll just go ahead and specify solve for r. How do we do that? So is there anything you would do before we just square root it? So how many x squareds here? So I'm going to switch sides just so it feels a little bit more natural. But do you guys agree that r squared is just now 2x squared? Okay. And then Matilda, I'm going to run with your idea. You said take the square root. Okay. I'll do the left side. It's r equals, and I'll add some yellow in here just to show what we've done. Now, normally if I introduce a square root, what should go in front of it? Plus or minus. Why didn't I put plus or minus? Yeah, we're talking about the length of a triangle. It doesn't make sense for it to be negative. So help me out here. I want to simplify this. Do you guys know the square root of 2? Me neither. Do you know the square root of x squared, though? It's x. So I'm actually going to get a nicer color here. I don't know why. We're going to try that blue instead. It's a little lighter. What? I'm going to try this blue instead. It's a little lighter. There we go. R plus R equals, well, an x comes out, and the root 2 is still in there, right? Now, does this feel kind of deja vu to you guys? Because in this triangle, how many angles are the same? 2 of them. And if I wanted to go from a leg to the hypotenuse, I just multiply it by root 2. And that's how I taught you guys in geometry to remember it. 2 angles the same, multiplied by root 2. We now have a way to go from the leg to the hypotenuse. Okay. Do you recall how we do the same thing for the other special triangle, a 30, 60, 90? And if you don't, it's completely okay. We're going to see it right now because we're just going to go through it faster than we did in geometry. Did I lose anybody on that first part just now? And let me rephrase that because that's a hard question to say, yeah, you lost me, Holloway. What questions do you have about this first part? Okay, I think I've made eye contact with most of you guys. There's really no questions? Andrea, any issues with this? It can be hard to speak up. Do you remember doing these? Okay. So I really want to stress, do not hesitate to ask me. Like you don't have to do this. Like just give me some sort of like you don't like I'll come talk with you. Cool. All right. So let's deal with this one. Anybody think without shouting it out that you remember the shortcut here? Okay. Well, let's work it out. Somebody looks like you might remember, and that's okay. You think you got it too? Okay. So do you remember why it's that way? Okay. So let's start. We're going to start, and it feels weird, but we're going to start with an equilateral triangle, which means all 3 sides are the same and all 3 angles are the same. If this is an equilateral, let's say that these 3 sides are the same. And it's going to look weird here in a second, but what must each of the angles be? The same. And be more specific. So angles, they're all the same, I agree, but what's that sameness? What degree? 60. Because all 3 have to add up to what? In every triangle ever, it's always 180. Now, if we take this, and we don't really need the whole equilateral triangle, but if I were to drop a line, a median specifically, straight down, that would bisect this angle also, and here's our 30, 60, 90. Okay, so that 60 degrees up top just got cut in half by that new line, and I'll draw this triangle nicer, but there's our 30-degree angle. Okay, so I'm going to take just this little piece, and I'm going to take it out, and we're going to look at a bigger one here in just a second. Right now, it's going to feel really weird, but all these sides of the big triangle are the same, right? Now, I could call them each x, but it makes this be x over 2, or 1/2 x, which is kind of gross. So what I think I just want to do is I'm just going to call this 2x and 2x. And if this whole length is 2x, this bottom part would just be, if we look at just the half of it, 1x, or just x. So it feels weird to choose 2x here, but if we started with this is 2x, and this is 2x, and this whole length is 2x, then we use this equilateral triangle to get over to this nicer 30, 60, 90. And it's not going to be perfect to scale, but let's say here it is, 30, 60, and 90. First question, which one is my 30 degrees? The top angle or the, why this one? Okay, well, how do you know that one's not? Like maybe I just tilted it. Love that. The smallest angle is opposite from the shortest side. So here we go. We'll just go ahead and mark it. This must be our 60 degrees right here and our 30 degrees. And let's just take out what we knew. This was 2x from our other picture. And now this length is what here? 1x. Now, you may remember it. You might have it written in your notes from yesterday, but recall we're just pretending like yesterday never happened. So I want you to Pythagorean theorem for me. I want you to find me this side. Use Pythagorean theorem. It'll take a little bit of scratch work. I want you to find me the third side that, notice, is not the hypotenuse. I'll even help you. I'm going to call it y for now, I suppose. X squared plus y squared equals 2x squared. I want you to solve that for y. I'm going to give you a moment. I'll come walk around so that there's questions and stuff. Here's our Pythagorean theorem about to be applied, and we're just going to try to solve it for y. All right, I need some help. Let's solve it for y, right? And I didn't specify it, but we'll just write the same thing, solve for y. And the first thing I want to do is, just like every algebra ever, I want all the y's on one side alone. How do I move this x squared over? I'll subtract it. Now, notice, and I want you to look closely at your page, did you have 2x in parentheses squared, or did you just have 2x squared like this? Are they different? Absolutely, they're different. The way that I've written it, the correct way, what's 2x times 2x? There it is. So if we go little step, this is our first line, right? If we just clean that up. If you only had 2x squared because you didn't include the parentheses, you've lost what we were really working with. You did a different problem. Okay, if I now wanted to solve it for y, I'll subtract an x squared from each side, right? And I get 3x squared. And now I'll take the square root one more time, and we would get y is equal to, well, x root 3. Now, when we look at this, you may recall that I asked you guys a couple years ago, or not asked, I just decided. One side of a 30, 60, 90 is the queen, the most important side. We have three sides. We have a short leg, we have a long leg, and we have the hypotenuse. Who's the most important here? The short, because check it out. If I have a short leg that's this long, how do I go from a length of x to the hypotenuse? You just double it, right? How do I go from a length of x to this long leg that is x root 3? What do we multiply it by? Root 3. And what we see is, in the way that I taught you in geometry, is the way that I remember them is 45, 45, 90, two angles the same. We multiply by root 2. In a 30, 60, 90, three angles are different. We multiply by root 3. Now, we have to keep straight which one that we're going. As long as we know that this is the longest side, times 2 is bigger than root 3, because root 3 is like 1 point, I don't even know, 6-ish? Is that true? I don't know. I don't even know what it is. Somewhere in there. Do we want this really quickly summarized? Okay. So it's going to be like really concise, and you guys help me out here. I'm going to keep it just split up. To go from leg to hypotenuse, and this is on my 45, 45, 90, right? Leg to hypotenuse, we simply do leg times, what do we multiply by on my 45, 45, 90 with two angles the same? Root 2. Now, we could switch it, and I'm not going to write the other one, but what if I wanted to go hypotenuse to leg instead? We divide by root 2. Okay, this is for my 45, 45, 90, and you don't have to put it if it's very clear, but I want to make sure everybody has 45, 45, 90, and you know that this is the one that's referring to. On this one, we have a few different ways we can go. Who is the queen here? The short leg. So I'm only going to talk from the short leg. If we want to go from the short to the hypotenuse, and we look just at this picture, and I'm going to make sure I can say that this is x root 3 now that we found it. To go from the short leg to the hypotenuse, what do we do? times 2 times 2. What if we wanted to go instead from the short to a, what's the other side? The short to the long. If we look at, and it's kind of hard to see, but I can see it still here. I'm going to let you guys catch up because I can already feel that I'm speaking and writing too fast. If I have a length of x on that bottom side, what do I multiply by to get to the long side? Root 3. So we just multiply times by root 3. Now, we are going to use this all over the place because you guys have grown, and I get it. Like, it might sound like I'm talking some smack, but I'm not trying to really do that. The unit circle seems so awful, and if the first time you learned it wasn't great, that sucks. I'm sorry. It's not bad. Like, if you have negative ideas about it, just forget about them. It's so much easier than you think it is, I assure you. As long as you know these, or at least have them written down, you don't even have to memorize the unit circle. You'll always be able to figure out where we're at. Okay. Feeling okay with this? At least kind of. Not feeling awful, at least. Okay, next question. We don't even have to write it down right now. When I say bow ties and butterflies, what does that mean? So if here's, we'll do a nicer circle. If here's a circle, and maybe, and you don't have to draw this right now because I'm going to help you out with yours. If we have this, how would you draw a bow tie? Draw a bow tie just in your margin. I'm going to be really judgy. Good. I don't even care where you drew. How would you draw a bow tie? Oh, yeah. Love it. Love it. Love it. Hate it. Just kidding. Yours is actually better than everybody else's, but you're doing, hold on, you're doing too much. All right. So, gosh, I'm cool. Bow ties and butterflies. Basil, just for the record, yours was legitimately the best bow tie. But this is all that I need. I don't need the knot in the middle. And notice, here's the butterfly version of it. We just add the antennae. Antennas. All right. Anyway, the reason that we talk about bow ties and butterflies is because as we're learning the unit circle, anywhere that we draw a triangle, and we'll do this on your big sheet here in a second, but anywhere that I draw a triangle, they're always going to be one of these 4 flavors. Bless you. Bless you. Which means each one of these little parts of it represent one part of my bow tie or my butterfly. There's one right triangle. Cool. Here's a different right triangle. And notice that they always start at the center and they always go to the circle. And then we just have these 4. What's up? What'd I do? Okay. So, well, that's better than before. Yeah. Okay. These are how we're always going to draw our right triangles, which means if I say let's draw a triangle in quadrant 1, it always goes up like this and drops straight down. Always goes up to the circle and straight to the x-axis. Whether it goes down or up, doesn't matter. The right angle is always formed with the x-axis. Now, as we start thinking about the unit circle, we're going to use this. The unit part of it. What's the unit part of the unit circle? I mean, there's a whole lot of it, but if I say unit square, what's the length of each side? I mean, all squares have the same length, but I mean, you're right. But that's how I started today. I said the unit circle is special because what is 1 on the unit circle? The radius. I couldn't tell if you said radius or radians is the only reason I didn't acknowledge. The radius of the unit circle is 1. Like, that's what makes it a unit circle. So let's start thinking about the unit circle. And we're going to draw one thing in our notes, and then I'm going to give you guys some time to work with stuff. So we're in special triangles. Now let's actually work out the unit circle. And I will let you guys work on your circle handouts that I gave you. I probably should have waited a little while first because I think some of you probably already have them done. But right off the bat, The unit part means what? Said it at the start. I said it just a second ago too. The radius is 1. The radius is 1. And the center of this circle, if we got to put a circle on the coordinate plane, where do you want the center of that circle to be? At the origin, 0, 0. Absolutely. At 0, 0. This is like the nicest circle that we could possibly come up with. Now, it turns out this relates exactly to radians as well, because if you go the whole way around the circle, it's 2 pi. Like, and that's where that number comes from, the nicest circle. What is this? 0, 0. Okay, it looked like a face when I look back at it. I feel like garbage, just for the record. All right. Radius is 1. You just laugh when I said I feel bad? No. Okay. So we're going to draw quadrant. I'm just messing with you. We're going to draw quadrant 1, and that's it. Now, yours might be better than mine, and that's okay. We're only going to do quadrant 1 together right now. So let's say here it is, and I'll even switch color so I can see the actual circle. Here's quadrant 1 of my unit circle, and it's not perfect. It's going to be better. There's that one. Nope. Oh, that one's actually really good. That one is really good. Okay. You don't have to have this in your notes, but it's not a bad idea to have it. Now, I'm going to eyeball it, and it might bug some of you depending on how good you are at working out coordinates. So here we are. Now, you don't have to shade and everything, but if we can pick out a pattern here, we're golden. And as long as you have those shortcuts, we're fine with it. Now, the quiz that I gave you, that handout, you'll see there's some blanks. I asked you to add the radians to it. I might ask you to add the degrees as well. We'll see. I got a new cube that does timers. So if I just want a 25-minute timer, I just do this, and it does 25 minutes. That's really cool. Thanks, I made it. That's not true. Yeah. Now it's paused. Okay. Also got chessboards and chess timers, so that's also cool. But check it out. This is quadrant 1 of my unit circle. Now, you're going to be asked to do a few things. I need you to know the special angles in degrees and radians, and I need you to know the ordered pairs around this, because there's a reason that we use those ordered pairs, and we'll connect those over the next couple days. But help me out here. If the radius is 1, the first 2 points that we get, we don't even need a triangle. There's no triangle to draw. This is 1 point on my circle. Okay. Now, on your sheet in degrees, what does it say it is? 0 degrees. Is there another possible number you could give me? 360, or any multiple of it. 0 or 360, right? Okay. Now, you guys, if we want to put them, I think it'd be nicer out here, realistically. What's this ordered pair if the radius of this is 1? Everybody agree that that's 1, 0. If we go 1 away, it has to be. Now, I don't know which way is nicer to put it. I would say out here in my mind, on your sheet, it's on the inside, but it's going to be a little bit bigger. This is 0 radians or 2 pi radians. Now, if you want to put 0 or 360, that for degrees, that's completely fine. But there's a nice easy point on my unit circle. Anybody lost with this part? We're just drawing 1 quadrant because it's really all we need. Now, what's the first nice angle that shows up on your sheet? We start at 0 and then we go to where? So I'm going to eyeball out 30 degrees, and I'm going to switch color for each of them. That's roughly 30 degrees. Now, just to be very clear, and I'm not going to write it here because it's going to get muddled and ugly, this is the 30-degree angle that I'm talking about. Okay. Now, I'm going to do it out here just like I did, and I guess I can write 30 degrees here, and that's all fine with me. Okay. Now we're at bow ties and butterflies, and it's at where it immediately starts clicking in. Where I've drawn this, I know I wrote the 30 degrees, which is why I couldn't decide if I wanted it or not. I'm actually going to get rid of it on mine just so it's a little bit nicer to look at. Can you tell me the length of that blue segment I just drew? It's on the unit circle. It has to be 1, right? So we're going to do some scratch work over here. And whether you include this or not is entirely up to you. But if you don't want to have to memorize the unit circle, you will memorize it because it's super easy once we see it. And you might remember even from before break. But it's super easy to work out also. I have a triangle in front of me that's roughly like this. My bow ties and butterflies says it drops straight down to the x-axis. Here is my first one. And I'll do my scratch work over here, but I do want to make sure it's like we can see it in here. There's my right triangle. And this length is 1, right? Okay, so I'm going to use my scratch work to sort this one out. Here's my length of 1. Is this right here the y direction or the x direction? So I hear a couple different things. If I look at this, does it change how is it changed vertically or horizontally? From here up, right? This is my y direction. And this is my what then? That's my x. Now, if this is my 30-degree angle, that's my right angle. What does this angle have to be? 60 is right up here. I'm not even going to write it. We're just aware that it is. What sort of right triangle do we have? 30, 60, 90. And you know the what part of it? You know the hypotenuse. Looking at the shortcuts that we worked out just a second ago, how do you go from the hypotenuse to the short leg? You divide by what? Divide by 2. Is y the short leg or is x the short leg here? Y is the short leg. So check this out. If I know that to go from hypotenuse to short leg is just divide by 2, and I know that this corresponds to some point on my plane, what was that change in y you just found? It was 1, and now it's 1/2. Okay, there's my y coordinate. This went up 1/2. Like that's all that happened here. What's x? Now that I have the short leg as 1/2, how do you go short to long? So we multiply it by √3, right? 1/2 times √3. And it's more common, instead of writing it as 1/2 times √3, which is what we're doing, that's really √3 over 1, right? So I think that this is just the square root of 3 over what? And check it out. Here's our first ordered pair. Now, once we get all of these, and we're only going to get these first quadrant right now, and then we're going to see how it applies to the second quadrant also. If you ever are struggling to remember which one comes first, here's all I think about. This point, is it further right or further up? This ordered pair, right, or this point, is that further to the right or further up? And what's bigger, √3 or √1? The √3 comes first. It's my x direction because it's bigger than √1. Okay, let's move to the next nice one. This is my 30 degrees, right? Well, that one was 30. What is that in radians? And how do we convert? We need a clever choice of 1. Well, how much is half a circle in degrees? Whoa, a half a circle. 180, and in radians it's pi. So remember, the last thing that we looked at, it's been a while. If I wanted to know the radians, I just take 30 degrees, and I do a half circle here and a half circle here, and we can conclude that this is pi over 6. We're just using that conversion between half circle over half circle. Pi over 180, you could pick 2 pi over 360 if you wanted. You could do whatever. We're going to do it this way for now. Next nice angle, I think Lei told me a second ago, was what one? 45. So I'm going to draw out to 45 as well. And I know it's about here. There's my 45 degrees. And notice the same bow ties and butterflies is in effect. Now, I'm going to do the scratch work the exact same. Is anybody opposed to me erasing that so I can keep them both up on the board? And by that, you have no idea what I'm pointing at. I'm going to erase this so I can do this next scratch work. Okay. We'll take a brain break here in just a minute. We're almost at a good pause for now. Okay. So here's my lovely triangle where I know that there's my 45-degree angle down here. And I know it's weird because we're writing it here just so it really stands out. There's 45 degrees. There's a right angle, which means that's also 45, right? Do you know any of the lengths of this right now? I don't know this y value yet. I don't know this x value yet. But do I know this? Because it's on the unit circle and this is a radius, what is this length on the triangle? Now, we have a special right triangle in front of us. Which special right triangle is it? It's a 45, 45, 90. How do you go from a hypotenuse to a leg on a 45, 45, 90? You divide by root 2. Now, this will not always be the case in future classes, but it is now. If I want to know this y value, I just take the hypotenuse, 1, and I divide it by root 2. What can't I keep in the denominator, though? That pesky radical. Well, what do I do to get root 2 out of the denominator? I'm going to multiply this thing by any choice of 1 that works really well, and it turns out that this is the best choice of 1. When I do this, the numerator is just root 2 over 2. What did we just find the y value was for this whole height? So if we're now looking at this ordered pair, it's root 2 over 2. And because it's an isosceles triangle, if this side is root 2 over root 2 over 2, I'm sorry, what's this side? Yes. So if we look, and I'm going to scroll up here, to go from the hypotenuse or leg to hypotenuse, we multiply by root 2, right? What if we're going the other direction? Yep, that's exactly where it happened. And then we just rationalize the denominator. Yep. And if that's root 2 over 2, then that must also be root 2 over 2 because it's an isosceles. So look at that. We now have the second ordered pair. Okay. There's one more ordered pair that we can get out of this. I think we can just flip the first one, right? Because if I draw the triangle, and I will draw it, I don't think we're going to do the scratch work here, though. If I now go up to this 60 degrees all the way up here, and I drop down and get my nice right triangle like we have been, notice it's the same as this first triangle, but the short and longs just switched places. So instead of being 1/2 up, it's now 1/2 over. And how far up this time? Root 3 over 2. And we could draw the same thing as we did before, and I'll sketch it out in case somebody's looking at it going, I don't understand why we can do that. If now's my 60s right here, and that's a 1, to get to the short leg, we divide it by 2, so now it's 1/2, and now we multiply it by root 3 to get to the y value here. That's all that's happening. That one shortcut will get us there. Now, you might have noticed that I skipped the radians on the last couple. There's a reason I did that. As we look at this, if you guys can count down from 3, you can do the entire unit circle. And we're going to see that all these triangles show up over and over and over. They just show up in different places. And let's just think real quick. Let's fix the radian part of it, and then we'll see where we can go. 30 degrees was how many radians? We wrote it here, pi 6. So if I go 30 degrees to here, if I go another 30, do you agree I've just gone pi 6 more? So pi 6 and then another pi 6 gives me 2 pi 6, or pi thirds. So all of a sudden, if I just keep adding pi 6 from that rotation and from another pi 6 to get here, and I know it looks different, it's because I'm not perfectly to scale, 2 pi 6 or pi thirds is where we wind up. If we go one more without having to draw any triangles or do anything wonky, can you tell me the ordered pair up here at the very top, my quadrantal angle? It's none in the x direction, and it's 1 straight up. And I just want to see the same thing with the radians happens. Here's 1 pi 6, 2 pi 6, 3 pi 6, which simplifies to what? 3 pi over 6. Oh, it's just pi halves up here. And all of a sudden, we have the entire first quadrant done. Now, don't really have a good idea for brain break, but I'm going to finish this, and I'm going to give you guys a few minutes. And if That was super unfortunate. We're going to see something here. And just so you know, like legitimately, 100%, this is going to be your quiz. It won't be Monday. I'm going to let you guys take it as many times as necessary. It's like 10-minute quiz where you just fill in all the blanks on this. Because if you have to look at it every single time, it sucks and you will not get stuff efficient. But there is a nice way to memorize this. So check it out. We just did this entire first one, right? Now, what you can't see on this, and it's okay if you want to add it or don't, is that here's the exact same picture that I just drew with these other pieces in. Okay, so there's exactly what we just did, just quadrant one. Now, if we look at this triangle right here at 120 degrees, and I know it's weird, but if we use bow ties and butterflies, if this was my 120, what's this angle right here? If there's 120, this must be 60, right? And this is still a length of 1? Oh, okay. Well, it's exactly the same. This triangle and this triangle are the exact same triangles. They're just flipped. So if this ordered pair right here was 1/2 root 3 over 2, and we just folded it over the y-axis, it's, yeah, go ahead. And I can see it's the exact same value. Now, if you remember the pattern that we picked out the other day, I don't know how many of you do. I'm going to put these other two on here. And I want you guys, without just saying them all, not to me right now anyway, is I want you to do the same thing for these points. The same thing is going to happen. Bow ties and butterflies, you're going to get a 30-60-90 or a 45-45-90, no matter which triangle you're looking at. Every single time I want to use those triangles. I want to see if we can get the whole unit circle filled out, and then we'll work on the radian stuff Monday or in a couple minutes if we need. Do you want a brain break or do you want to finish this part first while it's still fresh? Okay, I'll give you a second and then we'll come up with brain break ideas of some sort. I don't know that I have one, but I'll give you a minute. Cool. And I'll pause this. But I do want to pick out the pattern here, and you guys are going to see it immediately. I think some of you have already seen it. I'm just looking at the x values. Now, I'm going to say it as nice as I can, which means I'm not going to say square root of, I'm just going to say just 3, just that, okay? And then everything, every single point is a 2 in the denominator. So I'm not even going to say divided by 2 or over 2. I'm just going to say the numerator and see what happens. And let's just check. This is the first number, right? 30 degrees. Let's look at just the x's. 3 is the numerator. Square root of 3 over 2, right? I'm only going to say 3. 3. 2, 1. 1, 2, 3. Oh. 3, 2, 1. 1, 2, 3. If you can count down from 3 and you can pick whether x is negative or positive, it is everything. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. Let's check the y values real quick. It starts at 1/2, right? 1. If you can do 3, 2, 1, and 1, 2, 3, you have the entire unit circle at your disposal. That pattern will work as long as you can pick out what's negative and what's positive in each of these quadrants. There's nothing else to it. Now, for the radian stuff, we will hit it on Monday. It's really hard for me to not mention it now. I think we have enough time, but I'm just going to let us chill for the next 2 minutes. Cool. Awesome. Despite what the announcement said, there is not study hall in my classroom today. Oh.